Lesson 8.3, Trigonometric Functions. Trigonometry studies, among other things, the relationships between the sides and angles of a triangle. There are a lot of basic functions that we need to study, but the three we're going to focus on are sine, cosine, and tangent. To do this, we are focusing on right triangle trigonometry. It's a special branch of it. There's circle-based trig and other things like that, but we're going to focus on the right triangle here. So when I look at a right triangle, the first thing you need to identify is your hypotenuse. In this triangle, side Z is the hypotenuse no matter where you're standing. The other two words that we want to focus on are adjacent and opposite, and those do matter where you're standing. If you're standing on angle B, then side Y is adjacent. Adjacent just means it's next to. Across from that, we see side X. Side X would be called opposite to angle B. On the other hand, if you're standing on side C, across from you is side Y. That would be your opposite side. Next to you is side X. That is your adjacent side. So it matters where you're standing. Our three trig ratios are called sine, cosine, and tangent. It's spelled S-I-N, but it is not pronounced sin, it's sine. And we don't call it cos, we call it cosine. It's not tan, it's tangent. So when you set these up, I want you to always focus on making sure that you use the correct sides. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So for angle B, opposite over hypotenuse is going to be X over Z. Still for angle B, cosine is adjacent over hypotenuse, so it's going to be Y over Z. Tangent is opposite over adjacent, so it's going to be X over Y. If you switch over to angle C, your opposite and adjacents switch. So now it's Y over Z, and this one, your adjacent is X. It should say X over Z. So make that change in your book. That should be X over Z. And our tangent is Y over X. Take a minute to look at this. And if you notice, I have Y over Z here and Y over Z here. So the sine for one angle is the same as the cosine for its complement because we're dealing with the right triangle. We have the same situation here, X over Z and X over Z. Now look at your tangent. If we look at these relationships, I'm hoping that you notice that they're just reciprocals of each other. That can help you a lot later. So this is a lot of information to remember, and so we all use the acronym SOHCAHTOA. And it just, S stands for sine, C stands for cosine, and T stands for tangent. In all of these, O is opposite, A is adjacent, H is hypotenuse. So what we're looking at here, we can remember that sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tangent is equal to opposite over adjacent. This can help you keep your trig functions organized. All right, so let's talk about using this. In this figure, the first thing you're going to want to do is find your hypotenuse. So we're going to find our right angle. We're going to look across from it. No matter what, this has to be our hypotenuse. So our hypotenuse is the side DF. Now let's go stand on angle F. If I am standing on this angle right here, I've already labeled my hypotenuse. The other side that it's touching is its adjacent side. So this is adjacent, and this is opposite. So the side opposite angle F would be the side DE, and the side adjacent would be the side FE. Now let's switch position and move up to angle D. If I'm standing on angle D, the other side besides the hypotenuse that it's touching is its adjacent side. Across from it is its opposite side. So for angle D, the opposite side is FE, and the adjacent side is DE. So now let's use those with our trig functions. I want you to write these out. Sine is opposite over hypotenuse. That's our SO in SOHCAHTOA. So for angle D, this is our red angle. Opposite is the side FE, and hypotenuse is the side DF. Cosine, this is our CA, so it is adjacent over hypotenuse. For our angle D, our adjacent side is DE, and our hypotenuse is DF. That's an E. T, this is TOA, so it's opposite over adjacent. For angle D, opposite would be FE, and adjacent would be DE. What I want you to do now is stop the video, and I want you to go do this part. Fill out your acronyms here so you know what side you're looking for, and place the side angles in here. When you're done, resume the video to check it. Check it and see how you did. You should have these proper sides in place as well as your acronyms copied over. Now let's move on and look at how we use this. This time we're given a right triangle, and hopefully you recognize that 3, 4, 5 family in there. And what we're going to do is figure out the actual values of our sine, cosine, and tangent. So the first three, I'll use angle B. So I'm going to go stand on this angle. Always label your hypotenuse first because that does not change. Based on this angle, my opposite is going to be the side marked 40, and my adjacent is the side marked 30. So sine is opposite over adjacent, which is going to make this 40 over, I'm sorry, I wrote opposite over adjacent. It should be opposite over hypotenuse. That's OH. Hypotenuse is 50. And we can reduce that to the ratio of 4/5. Go ahead and try cosine. Think about your ratio. For cosine, it should be adjacent over hypotenuse. So my adjacent angle, adjacent side is 30, hypotenuse is 50. This reduces to 3/5. And finally, tangent. This should be opposite over adjacent. Our opposite side is 40, our adjacent is 30, giving us a ratio of 4/3. I want you to stop the video now and do 4, 5, and 6 on your own, and then resume the video to check it. Hopefully your ratios reduced the way I'm showing you. To get full credit for your notes, you should have this part filled in as well. So why do we not calculate the sine of angle A? Angle A is our right angle. And we're not going to use SOHCAHTOA for the right angle. We only use it for the two acute angles in the triangle. When you take pre-cal, you will learn memorized values, and you will find out that the sine of angle A, or a 90-degree angle, would be 1. All right, so now let's take a minute. We're going to look at this in your calculator. We're going to do this part pretty quickly because most of what you're going to do, you're not going to use your calculator. I just want to show you something. The first thing I want you to do is set up your calculator so that it's always in degrees. So you're going to turn it on, go to the home screen, choose 5, which is settings. After you do that, you're going to choose 2, which is your document settings. And under your document settings, you're going to see something on angle. You're going to want to set that to degrees. It probably already is, but it may be in radians, and that's a problem for what we're going to do. At the bottom of that page, you have the option to make this your default. I would encourage you to do that so it's not likely to kick back into radians. When you go to pre-cal again, you'll probably find that you use radians more than degrees, but for geometry, you need to stay in degrees. Okay, so we're going to take a minute and learn how to type these into our calculators. There are two ways you can do this. If you look at your calculator, you have a trig button. It's right below your control key. If you press that, you get a menu that shows you all of the different trig values or trig functions. So you can just click on sine, type in 30, and hit enter. When you do that, you should get 0.5. Now let's go on and do the cosine of 30 degrees. When you type that in, you should be getting 0.866025. Since this one's the nearest tenth, we're going to write that this is approximately 0.9. And you can do the same thing for tangent. You should be getting 0.57735, which is approximately 0.6. Now there's a second way you can do this using the alphabetical keys at the bottom. You can simply type in SIN and then parentheses. And if we're going to do our 60 degrees, we type in 60 and close it. If you don't put the parentheses, it will not work. So take a minute, stop the video, type in these values, and make sure that you can get them correct. Hopefully you got these correct. And when we talk about relationships, we can see that the sine of angle A is the same thing as the cosine of angle B for complementary angles. All right, so let's use this to solve some problems now. To do this, you need to always focus on finding what you need. So in our first one, first thing I'm always going to label is my hypotenuse. And then I'm going to find the angle that's involved. Based on that angle, I know that this is my adjacent side and this is my opposite side. So since I'm using O and A, I'm thinking TOA in my SOHCAHTOA. Always keep this in mind because it'll help you figure out which function to use. So I need to use tangent. So I'm going to write tangent of my angle is equal to opposite over adjacent. And so the only thing that can follow a trig function is a degree measure. You can't ever put an x or ever put the side length in there. So to solve this for x, what I would need to do is multiply both sides by 13. And so what I can do, x is equal to 13 times the tangent of 32, which you can type into your calculator, and you can find that to be approximately 8.1233. Go try to select the proper trig function on the next one and set that up. Again, here's our hypotenuse. This is my angle. Based on that angle, I have an opposite and an adjacent. These are the two that are involved. It's O and H. So that's so. So I'm going to set up sine of 57 equal to opposite over hypotenuse. To solve this, I'm still going to multiply, but what I'm multiplying by is my x. So now I have x times the sine of 57 equal to 10.8. So to solve for x, I need to divide by the sine of 57. So what I'm typing into my calculator is 10.8 divided by the sine of 57 degrees. And when I do that, I'm going to find that it's approximately 12.8775. Stop the video now and try the next triangle. All right, the last one is our word problem. Once you read it, you're going to see a setup similar to this. So again, when we do our labels, we should have our adjacent here and our opposite here, which leads us to the equation tangent of 5 degrees equals 150 over x. I want you to solve this one and then go figure this one out. To figure out this last one, you're going to be solving for y. Good luck. Get your online work done.